Okay, I want to get started by showing you a little animation on this frequency response idea. Remember, what we're doing is we're feeding in a frequency, actually a whole range of frequencies, into our system and seeing how the system responds to those frequencies. From that, we can tell a lot about what the system is, how the system is going to react to an input that we put into it. And let me bounce over here to this little animation here, and we'll see if we can understand this a little bit better. In this case, we've got a simple system. We've got a spring mass damper, friction in this case, and we're going to drive this input, this U, back and forth with a sinusoidal input. It's going to be the same magnitude, but it's going to vary in frequency as the animation progresses, from a very slow cycle to a very fast cycle. And it's going to record not only the input, but it's also going to record the output. And there's a couple things I want you to note. We're going to put a sinusoidal input in, and we're going to get a sinusoidal output out. But the output is going to vary from the input in phase and magnitude. Phase and magnitude. Okay, so let's just watch this here real quickly. And we get it started here, and we have a sinusoidal input, and you'll see here the trace of the input and the output are almost right on top of each other at the beginning. But now, as we start speeding up in our frequency, our input stays the same, but our output increases. And this is the resonance right in here. Now, as we go further, higher frequency, what we end up doing is shifting in phase and getting completely out of phase, and our output diminishes or attenuates, and we don't get much output out of the system. Okay, so thinking about this from a control standpoint, we like this area in here because our output is doing exactly what our input's doing. So in these frequency ranges, down here in the low end, we like this. Okay, we don't like this at all because the system is not doing what we want it to do. We're putting in an input and it's doing something crazy. It's magnifying that input and shifting it in phase. And then also up here at the higher frequencies, we're not getting much out of it at all. And so we don't like any of this near and past the natural frequency of the system. We like this slower frequency down here because it is replicating our input with high fidelity. Okay, so this is the whole idea behind the frequency response and the Bode plot, and figuring out how fast we can drive this system and still have good fidelity in our output matching our input, and then ultimately being able to shift this through some mathematics, adding of poles and zeros, to get a better replication of our input and by our output. Now, here's how we're going to represent this. This is a Bode plot, or similar to a Bode plot. Ours will be just a little bit different. But what we're going to be doing is actually two plots. So the Bode plot is made up of two plots. One is magnitude, which we see in here, and the other is phase. The magnitude is the ratio between the input and the output. The phase is the phase shift between the input and the output. Okay. Now, along the x-axis, we're going to have frequency. Okay, so we're going to go from very low frequency on this end to very high frequency on the other end. And so with these two plots, we can start understanding how the system is responding. Now, the simple system only has one natural frequency in it, and so we get this resonance here. We can see that at this point. Now, most systems have many natural frequencies in it, and we'll have multiple peaks in here, but that's a little bit further on. Now, what we want is, and what we're looking for, is a amplitude ratio of 1, or magnitude ratio of 1. Because that indicates that our input and our output are exactly the same, and we're going to want a phase shift of 0. Okay, so that, from a control standpoint, is what we're looking for in our system. Okay, so that's just a simple example to get you started on the idea of frequency response and the whole concept of Bodie plot. So we'll continue that on in the next series of lectures.